Good morning, good afternoon, good welcome everyone to our webinar about next generation wireless connectivity for Industry 4.0. So Industry 4.0 is all about data, and connectivity is the tool you need to use to be successful in the new industrial revolution. But what does this really mean? This means that we will be looking into what is really Industry 4.0. We look into the technologies that can solve the business challenges of Industry 4.0. We talk you through some various use cases and applications, and we will also finish off with Q&A at the very end. So we are looking forward to receive your questions. My name is Malena. I will be your moderator today. Sabrina, my colleague, will take care of the Q&A session. And our key speakers today are Ludger and Pelle. So first, some housekeeping things. If it's the first time you attend our webinar, so this is just explaining how to place a question. You see this on the slide. As I said, we really look forward to receiving those. So get those going throughout the webinar, and we will make sure to allocate enough time. So our first speaker today is Ludger Bögering. He has more than 15 years of experience in energy and industrial automation market. We're very happy to have him here today. I'm jumping to our next speaker, Pelle Svensson. He has a long experience in the business, and his areas of expertise include short-range wireless connectivity and industrial automation and communications. I should have said this in the beginning, but this is going to be an interactive webinar, and we will actually start with a poll right away. And I'm launching the first one for you here. We would like to know, what short-range connectivity technologies are you planning to implement for your business? Please select all that apply to you. We did experience some technical issues in the morning session, and we learned that if you keep the presentation in not full screen mode, that can be easier to vote. Like, some people couldn't vote, but I actually see now questions coming in, so it seems to work. I will close the poll, and let's look at what you have answered. So the majority of you are actually using Bluetooth BLE followed by Wi-Fi. Thanks a lot. So just one more poll before we jump into the presentation. Basically the same thing. What cellular connectivity technologies are you planning to implement for your business? And I want to say something I forgot in the beginning. This webinar will be recorded and sent to you after the webinar. So you do not have to do anything, but if you would like to receive the slide deck, please send an email to webinars@u-blox.com, and I will get that over to you. All right, so let's look at this last poll. Okay, it's a bit split here across the technologies. Very interesting answers. I'm sure Ludger will talk a bit more about this, and I will try to get back to the presentation. All right, over to Ludger.
Ludger, I think you are muted.
Yeah, sorry for that, and starting again. Welcome to the webinar, and good morning, good afternoon. I'd like to start with the short introduction into Industry 4.0. What's behind that? And 4.0 means there is a fourth generation moving into new products, new service innovations. So looking at this graphics, I guess you know already and have already seen that. So especially when we focus on the cyber physical system, that means the machines are used to solve who, what, where, and what, when challenges, and the cyber physical system is going beyond business efficiency and a business model around connected assets. So the fourth generation is going across main application areas in OT and IT, in a factory, with factory automation, with process automation, with the HMI and production IT, and also logistic and warehousing, as well as monitoring and maintenance. So in the industrial evolution is a journey. It's not really a fixed point. It's a journey from a support of operation into real business optimization and finally providing customer value. So in the next slide, I give you some hints on what is predicted in the digital factory and the growth of technology. And on the left side, you see an overview of the prediction coming from ABI research, where you see the different technologies and clearly wireless is getting more attraction in a factory, and then especially its low power wide area, LTE, but also Bluetooth, Wi-Fi. These are technologies which are increasing. And looking on the right side, a bit more focused on these four technologies: 5G, Bluetooth, Wi-Fi, and low power wide area, LTE, which is finally Cat 1, M1, and NB IoT. So there is the huge increase over the next coming years, and what you also can see is that 5G will start potentially in 2024, 2025, and not earlier. And we will see talk about it a bit later. What is the reason for that? But basically, it's definitely the specification is currently ongoing, and at that time later on we will have then the products ready. So going a bit deeper in the next slide in what happened on 3G not on 3GPP, on what the industry is motivating to go into that direction. And the transformation and the investment is pushed and motivated by increasing productivity, increasing, of course, the revenue and profitability. But there is another very important point. It's really bringing products in a shorter time frame into the market and optimizing the production process. And that's not only in the process itself. So it's really from the resource, from the raw material up to the end customer. And I mentioned already maintenance and predictive maintenance, and that's one of the key elements to optimize the production in a way that it avoids unplanned shutdowns. So that's all in all give the chance for these companies to transform their business. Going to the next slide, just a message is really, it's not just transformation, it's not just about new things, it's really how to do things differently. And we can see that in that slide following, right, thanks, which is giving you an idea of activities, and starting from the left with the predictive analytics, which is definitely giving the chance to learn more about a machine, to give the chance of mining informations out of the operation and using this historical facts and making predictions in direction of what the machine is doing, and potentially when it makes sense to start service. So we're looking at big data analytics. This is the chance and the option to get more informations out of the hidden pattern of production, unknown correlation, market trends over a spread area, seeing customer preferences, seeing other useful information which helps to organize the business decisions. Or looking at the asset management, and asset management it's a bit more than just an asset. It's really including design, including construction, commissioning, operation, maintenance, decommissioning, or replacement of equipment and facilities. And last but not least, talking about augmented reality. So augmented reality gives really the chance to computer mediate activities in a factory environment, and that helps, for instance, in service cases or even in quality assurance cases where the people are looking exactly what happened in a machine, how to bring that machine as fast as possible back into reality and in real operation. But on the other side, really getting computer-aided and computer-mediated help to secure the quality of a product. Let's continue with the second poll.
Thank you, Ludger. Yes, let's try if this works. Yes. So please answer this poll for us. We would like to know, for the factory automation area, which wireless technology do you intend to use? Select all that apply. So I'm seeing answers coming in, and I will leave it open for just a few more seconds. All right, thank you. I will go ahead and close, and then we will look at what you have answered. Okay, so it's quite even, but BT, BLE, and Wi-Fi seem to be the top two. Thanks a lot. I am now launching the second poll. And it's basically the same question, but for the process automation area, which wireless technology do you intend to use? Select all that apply. And while you're doing that, I would like to remind you again about the Q&A. I saw some questions came in already, but please add some more. Just send those in. All right, so I'm closing the poll, and we will look at the results. So here's really the Wi-Fi, also the LPWA, LTE, BT, BLE. Very interesting. And just one more poll before we jump into the presentation. And we'd like to know, for the remote maintenance and control area, which wireless technology do you intend to use? So we really appreciate that you are answering these polls for us, because we really want to receive your feedback for our future applications. All right, so closing down this one, and now we will look at the last results, and here we can see 51% of you answered LPWA, LTE, and then 37% Wi-Fi, followed by BT, BLE, and 5G. Thanks so much for participating. We jump straight back into the presentation, and I hand over to Pelle, I think.
Yes. Hi, everyone. I will guide you through one part of a couple of new enhancements of the technologies that we are working with in u-blox. Next slide. First, I will inform you of what we are working. You could probably understand from what the questions we have asked you already. The u-blox have been providing wireless solutions for decades into different industries and applications, as you can see on this picture here. Positioning, where we use information from satellites to provide high accuracy outdoor position for devices like cars and others. Short range, which is currently focusing on Bluetooth and Wi-Fi, to provide short distance connectivity in a number of different applications, from streaming entertainment data inside a car to exchange data between cars for safety applications, and finally into the IoT area where sensors and gateways provide connectivity in for example, manufacturing sites. And the third technology leg is our cellular technologies like 4G, low power, wide area, and 5G that will allow wide area connectivity in all of those scenarios mentioned. Next slide. First two examples from the real manufacturing world using wireless modules from u-blox. To the left you see HMS Network, a Swedish company, a leader in industrial communications that has support for majority of industrial field bus protocols. Wireless is among their product portfolio a growing part. Here in the picture exemplified with a product called the Bolt. It's a rubber type small bolt that is being connected to a machine or cabinet, and the device providing easy to use Bluetooth or Wi-Fi connectivity to the machine from an off-the-shelf human machine interface or tablet. Inside the machine it uses serial or Ethernet cables to connect to the devices inside. The second example to the right is from our partner Trion, who have developed an industrial condition monitoring solution. Consists of a sensor with using a large-scale mesh network from another sensor, Wirepass, that sends the data from the machine health to the cloud via a mesh cellular gateway. All the products including u-blox components. This is a solution that Trion have developed for pump manufacturer Sulzer in Switzerland. Next slide. So let's take a look at enhancements in the technology areas then that we believe will go into next generation industrial application. A little bit why we think so. I'm going to start with Wi-Fi 6. Yet another version of Wi-Fi. Why is it needed? And more devices are using Wi-Fi, providing later technology versions, providing higher data rates, enabling new use cases. Basically, we get into the position where the network sometimes is getting crowded, a lot of devices, and instead of building out the infrastructure, Wi-Fi 6 could be the solution. Because with the crowdedness in the 2.4 or 5 gigahertz, we can see some decreased user experience. And as previous generation of Wi-Fi has been pumping up the speed, I would have to say that speed is not normally not an issue when we're using Wi-Fi in IoT applications. It's actually the congestion and how the network handles lots of devices. And 802.11ax, or Wi-Fi 6 as we also call it, is made to solve the problem. As you can see in the picture, much more devices in the size of an infrastructure. The problem is solved by redesigning how the network operates, taking some of the best practices from LTE technology. With this frequency division multiplexing, OFDMA, the access point in the network can communicate with multiple client devices in the same message instead of one message per device. The second bullet here is battery life. There is a feature called target wake time, which is a way of negotiating how long to stay asleep between the access point and the client. Of course, the access point is not sleeping, but some battery-operated clients can stay in low power mode for much longer time, extending the battery life for small battery-operated devices. With wider and multiple simultaneous channels, MIMO, the data can go up considerably higher than previously, reaching several gigabit per second. Important to notice that in contrast to Wi-Fi 5, 802.11ac, Wi-Fi 6 can operate on both 2.4 and 5 gigahertz band providing the same user experience in both bands. As I mentioned before, for IoT application, we think the handling of more dense networks and the low power consumption feature are clearly the most important ones. Next slide. Recently, FCC, our regulatory body in US, decided to open up more frequency band for non-licensed operation, the so-called 6 gigahertz band, as you can see in the picture. This consists of more than 1.2 gigabyte of spectrum that will be available, as FCC explains it, to benefit the American public. The wireless industry have proactively developed Wi-Fi 6 to be able to operate in the 6 gigahertz band. So chip and modules are soon to come out that can support and operate in this band, extending the number of devices that can operate on this Wi-Fi networks. Next slide. A few years ago, more than 3 years ago, Bluetooth 5 was released, and that was a big step for Bluetooth, enabling the technology to go into much more application and use cases. There are three main groundbreaking technologies, enhancements to the technologies. The first one being the 2 megabit per second physical data rate, which doubles the amount of data compared to previously that can be transmitted per time unit. As a result, reducing the power consumption to half to send the same amount of data as previously. And of course, less active radios in the air will result in improved coexistence with other 2.4 gigahertz radio. Second, the two new modulation options have been introduced, 125 and 500 kilobit per second, which extend the range up to 4 times using the same output power as 1 megabit per second. In line of sight, that represent more than 1 kilometer, and actually on the beach outside of our office in Malmö, a sunny day, we were able to have a connection established and keep a connection over BLE long range up to 1.4 kilometer, however with a quite low data rate. Next slide. In a Bluetooth mesh network, nodes are configured for different roles. The so-called relay nodes will listen to all the traffic and everything they received. From neighboring nodes, they will just retransmit, by that extending the range of the network well beyond the capability of an individual Bluetooth link. This is referred to as flooding mesh. It includes, the flooding mesh technology includes several mechanisms to prevent overload of the mesh network. For example, never repeat the same message twice. Low power nodes running from a battery can of course not be listening all the time. They will have to rely on a friend node that will, while the low power node is sleeping, cache messages and forward to the low power node once it wakes up. It's important to point out that Bluetooth 5 is not required to run a Bluetooth mesh network. It can operate on any Bluetooth 4, a Bluetooth Low Energy system with a software update. Bluetooth LE is frequently used in location applications. The left picture shows how it was done until recently, where Bluetooth anchor points are using the signal strength from asset tag to determine the distance to the tag. And with multiple anchor points, you can calculate an approximate location of the tag. In Bluetooth 5.1 that was introduced a year ago, the direction finding feature is being added, which means that anchor points are now equipped with antenna arrays. In addition to the signal strength, they can also determine the angle from where the tag is transmitting. As a result, the solution with multiple anchor points in combination with location engine, a software package, we can now calculate location with much more improved accuracy. Next slide. The latest revision of Bluetooth specification called 5.2 was released earlier this year. It includes features to support synchronized audio streaming over Bluetooth Low Energy. So far, audio streaming has been supported by Bluetooth Classic only, but this is now a step into also making BLE devices able to stream audio. With the introduction of isynchronous channels, Bluetooth 5.2 will support synchronized communication over multiple channels. What does this have to do with industrial communication? Now, we say this isynchronous channels mechanism might open up for improved real-time performance in Bluetooth LE, also for industrial application. We will look into this with interest and see where we can add up. And now back to Ludger.
Thanks, Pelle. Yeah, let's talk a bit about 5G. And so 5G, what does it mean? 5G is, in my point of view, it's an umbrella for not only different use cases, it's really also an umbrella for different technology putting together in one frame or name. So there are multiple evolutions in 5G in the 3GPP, starting with release 15, but it evolves from LTE-M and NB-IoT if we are looking into the lower categories. So 5G, it's complementary and it's underpinned by 4G. So it enhances 4G use cases with these three main points like eMBB, ultra-low latency, and massive machine type. And further, it enables new spectrum, adds new radio, new interface to it, and especially to reach the targets mentioned in this three use case groups. It introduced a new core network and also network innovations like slicing, edge computing, and virtualization. So giving in the next slide some examples where this technology will be used and can be used. So starting with the AGV, which is then, of course, the clear requirements for ultra-low latency communication. So that can be covered there with 5G. Then we have the sensors, which for sure can be connected with the MMTC and still already with LTE-M, NB in the current and in the future releases. Looking at the operations control, of course, there is a lot of data, and enhanced mobile broadband is then the right solution. On the other side, looking on the robots, of course, there is again the ultra-low latency, the right solution, because we are talking about supporting mission and system critical activities in that area. And not to forget, finally, we are talking about positioning, and not only for the AGVs, of course, as well for the whole logistic chain in a factory environment. So let's go into the next slide with some more details on the 3GPP specification. And keep in mind, when we are talking about, for instance, release 15, release 16, that the availability of this specification means availability of products is 1 to 2 years later, because after finalizing the specification, it takes some time for the industry to create the chipsets, to create and implement the network. But going a bit into the details. So as already mentioned, we have release 14 and 13, 14 available. When we are talking about the low categories, Cat-M, Cat-NB 1 and NB2, these are already available and people are implementing it in all their applications. But as mentioned, release 15 and 16 will enhance these functionalities with, for instance, less power consumptions, reduced latency, extended range, smaller cell support, and even TDD support. So, and looking a bit more into the ultra-low latency direction, there indeed we see some new definitions because the implementation into the network requires some changes, and therefore there is the new definition of NR-IoT, which is new radio industrial IoT, and that takes care about the requirements in direction of the ultra-low latency, and as well with the NR Lite, which is targeting a bit more the direction of reliable low latency, not really the ultra. But when we are talking about industrial automation, reliable communication is essential. And not to forget the higher categories. We already in the phase of release 15 in 5G, which means enhanced mobile broadband, of course, with the target of covering smartphones and all this stuff. And but also there it's going into the next phase in release 16 to cover there some further topics also for the industry 4.0. So yeah, having said that, in the next slide, let me again point out that it's not the focus to use technology. It's really that technology helps to create value, and that means finally, depending on your use case, and you should select the technology which helps on that point. Melina, time for the next poll.
Thanks, Ludger. Yes, we have 3 more polls. We said it's an interactive webinar, and we would like to know, or we would like to ask you to select up to 3 features that you are most interested in, and there's a multiple choice, so you can select the ones that are most relevant for you. So I really see all answers coming in, and so I'm just flagging again for the Q&A. We have got some questions, but we have allocated time in the end, so you can just still submit those if some question arise during the presentation. All right, so closing this poll, and let's look at what you have answered. Okay, so low power, the top one, I think it was also in the morning session, same, and 60% answered reliability, followed by latency and response time. Thank you very much for participating. I'm just launching the second one. Yes, it's working. Okay, how likely are you to use Wi-Fi 6 for your connectivity in? So this is more like a future perspective, the coming year, the next 2 years, the next 3 years, or more than 3 years, if it's a very long-term project, let's say. Giving you some seconds to answer. All right, so let's look at the results. Okay, 44% are looking for the next 2 years, and the rest is a bit split, but more than 3 years, 90%, and the coming year, 17%. Thanks a lot. Very interesting for us to know. And now I promise this is the very last poll. We would like to know for cellular connectivity, are you considering implementation of a private network? So this is a yes or no answer, really. And giving you some seconds to answer. All right, so that's 30 seconds. I'm closing the poll. Let's just take a quick look of this. So it's 60-40. Yes and no. Okay. Yes, once again, thanks very much for answering all our questions. Now we will continue with the presentation, and I hand the word over to
Back to me.
Ludger.
Yeah,
Yeah.
exactly. Yeah, let's talk a bit as a next step regarding architecture. And first, I would like to remind you in the next slide a bit about the value of using wireless technology. But again, clearly the message, not one technology fits all requirements, so that there will be always a mixture. But coming back to wireless, definitely wireless will reduce the investment cost, and that means laying cables, implementing into a factory environment. And that means finally also it's easier to implement, or finally means rapid implementation. And that connects to giving more and better information on a activity on the factory floor, and also improves the operator safety. And having said all that, in total, it increases the flexibility and also allows the scalability of such solutions into a factory environment. And if I'm comparing in the next slide a bit the old architecture, or that's the traditional architecture, with the Industry 4.0, the new architecture, the main point I want to go through is in the traditional architecture, we had this separation between IT and OT, means between the business planning and logistic and the operational part. And in the new architecture, we don't see anymore this separation. So it's all connected between the business logic and the lowest level of the operation. And in addition to that, and this allows new business models, new activities in direction of services from OEM side, who provides machines, who provides sensors, give the OEM the chance to connect directly to their devices to start predictive analysis and asset maintenance by, for instance, allowing to bring a new firmware into a device once they see some trouble in that environment. But not only that's it, this architecture changed also when we come into the next slide about what happened when we are talking about the network infrastructure, and in this specific case for the implementation of the non-public network or the private network, however you want to call it, but it's mainly called as non-public network. And we have this 4 different implementation scenarios in general, starting from the left with a complete private implementation, which means a public cellular network is isolated completely from a factory environment and the factory network. And that means in a factory, you have your private network set up. So the second one is it's more a hybrid implementation, which is a shared RAN, means the antenna is shared, but still user plane for the user data and the control plane is part of the factory environment, but simply the RAN is shared. And the second hybrid implementation possibility is that still the user plan is in the factory environment, which secures user data in the factory, but it's controlled by the public network and the public network operator, so that the control plan is is shared, and also the RAN is shared. And the last one is the complete public implementation, which we already know by all the implementations which you see with the so-called APN setup. So let's talk a bit about, in the next slides, about u-blox solutions, and it's simply give you a quick and short small view into the cellular products with the next slide. But the main point we have seen in the past, or the main points we have seen in the past, is that the industry has strong requirements into cellular products, and the one is device longevity, talking about lifetime about 10 years and more, and not only operational lifetime, even availability. So complexity, so deployment of devices, this needs to be reduced from the complexity and makes it as easy as possible. And also, when we are talking about communication, security is a real topic in that area. And also there we take care, and let's go into the next slide to dig a bit deeper in what does it mean, longevity. And we started a couple of years ago already with the design of a chipset for the cellular communication, and that's not a new topic for u-blox. We are doing it already since 15 years for our positioning products, and doing that allows us to be independent from third party on the key components, especially on the LTE and the GNSS chipset. Having said that, it delivers roadmap stability, because we have the chance to influence the roadmap as we like to do that. And this allows us a long-term support across the whole platform. That means really down to the chipset level, and simply by having the full hardware and software ownership. And that finally helps you to, of course, scale your business, but also being as efficient in the implementation. And going to the other points of complexity and, of course, security, there we see the concerns in the market, and we take care about that by providing an infrastructure which protects the device. And that protection is not only an end-to-end security just by securing the data transmission. It's, for instance, providing a chip-to-chip protection so that the communication on the board between MCU and the module is secured. That we provide an infrastructure to handle and manage the key environment and the keys. So taking care that the keys are secured, stored in the device with a real secure element, which, by the way, then allows us also to store all the SIM credentials in the module. And by enabling the EUICC process, so allow the switching of an operator, this definitely simplifies your logistics and management of different versions of your products, and of course reduces the BOM. And on the other part, reducing the complexity means also allowing the simple connection to all the cloud providers by providing real zero-touch provisioning. And this is also essential in implementing a huge number of devices. And giving a quick overview in the next slide, again, it's only a small part of the whole portfolio, but focusing on the SARA-R5. If you require, let's say, the standard secure device, then it's SARA-R500S. If you are focusing on ultra-low power applications, then it's a 510S, the right product. Or if you intend to use communication plus GNSS, then it's the R510M8S, the right product. And in case you just still need 2G fallback, we also provide a right solution, which is SARA-R5 Series. So one real good achievement we have already done with the u-blox with the chipset, with this our own chipset, is this new GCF certification for IoT chipsets, and we are the first one who reached that with our u-blox chipset, and that's a great achievement. But not only this allows to ease the complexity. In the next slide, let me talk quickly about our extended offering by providing communication as a service. So if you intend to make to optimize and ease your life by using additional communication services, we added that to our portfolio, and I'm happy to introduce what we recently acquired with ThinkStream. So because what ThinkStream provides is a connectivity solution for industrial applications, so enables enterprises to easily connect devices, and using all the elements of ThinkStream so that you can manage the device, get the data, having the right interface to your enterprise, but also allowing efficient communication by using MQTT, a real industry standard on that, and bringing to the customer a predictable cost starting from one device up to a scalability of thousands of devices. So, and finally, providing an environment or network that allows to cover up to 190 countries. Pelle, it's yours now.
Yep. Okay. Now a short overview of the u-blox Bluetooth and Wi-Fi portfolio. And I would like to start with the explanation of two different architectures that our modules support. To the left is what we refer to as host-based architecture. There is a Linux computer in the architecture running the majority of the software, as you can see on the top there, including application stacks like Internet Protocol stacks, Wi-Fi stacks, and the upper layer of the communication stack. The firmware in the module is normally operating the lower level of that stack. In this architecture, the application developer equals the customer has full freedom to develop applications for any wireless use case. It requires, however, some effort, R&D effort for the wireless part, much more than the second architecture that we present in the two right columns. This is what we refer to as standalone. In the standalone architecture, all wireless software parts and hardware parts run on the module. The radio, antenna, stack, wireless use cases, all of that is integrated in what we call the Uconnect Express software package that comes pre-flashed with a module. It is the fastest way to add wireless connectivity to a device. Plug in that into your microcontroller via an interface. With few software API commands, the wireless use case is fastly up and running. Uconnect, as I mentioned, Uconnect Express comes pre-flashed with all our standalone modules. In this architecture, it's also possible for customers who want to make a very small device to integrate the application if it fits into the memory size in the module. This is what we call open CPU architecture in the standalone mode. So everything runs on a single component. This first table describes some of our standalone modules that has Uconnect Express pre-flashed. Everything from the left, ultra small ANA B1, which is 6.5 times 6.5 millimeter with an FCC approved antenna integrated, all the way up to the high performance solution that can work as a main MCU in a more complex device design like the Nina B3. Powerful MCU, 1 meg flash, 256K RAM. I also want to highlight the Nina B4, the latest part of our portfolio that supports Bluetooth 5.1 that I just described with direction finding, and in addition it can operate up to 105 degrees Celsius. These modules can be used with a Uconnect Express in Bluetooth mesh solution, so that can be pre-flashed into the module. In addition, the Nina B3 and 4 are capable of also running Zigbee and Thread in the open CPU fashion. And in addition, via our partners multiradio and Wirepass, the modules can also be used in large-scale, low-power mesh solutions. Next slide. Here's an overview continuous with an extended range of modules that are open CPU only. Here we're also adding UFL connectors for external antenna, easy integration of external antenna into the design, as well as some modules with built-in power amplifier for maximum range on the Bluetooth radio. Same as previous tables, these can run mesh, Bluetooth mesh, Zigbee, Thread, and again via partners, also large-scale, low-power mesh, which is highlighted in this table. Finally, an overview of a selection of our Wi-Fi and Wi-Fi Plus Bluetooth combo modules, some in the standalone architecture and some in host-based architecture. The one to the left, Nina W1315 and Odin W2, are the standalone that comes pre-flashed with Uconnect Express and has built-in cloud connectivity and has recently been qualified by Amazon Web Services. To the right on this table, you see 3 host-based modules, and to the really right, Jody W3, which is the first one that supports Wi-Fi 6 and Bluetooth 5.1 in a combination. The host-based modules, as I mentioned before, are normally operating in the Linux host architecture, but with our partner Clarinox, you can get assistance to port those into any kind of RTOS. Okay, summarize. We have now been describing a couple of wireless technologies, low power, wide area, 5G, Wi-Fi 6, and Bluetooth 5, which are the latest contributions to the short-range technologies. And they we've shown how they emerge, and they are still being developed into the future, and they fit very well into Industry 4 applications. We've also shown you some examples how the technology fit with some live real description from the manufacturing sites. And as you also saw, we have a range of modules and services that can help you to reliably and secure your Industry 4 communication applications. And now back to Malena.
Thank you, Pelle. Thank you, Ludger, for this very interesting presentation. I will just quickly mention, if you want to know more, watch another webinar. We have a special section on our website. You find information on the SARA-R5 Series, IoT security, or mesh network. So go and have a look. You can watch them on demand anytime. If you're interested in getting in touch with us or getting started, here are some platforms. Also, if you want this presentation, send an email to webinars@u-blox.com. So with this, I will hand over to our product communication expert, Sabrina, who will take your questions.
All right, thank you, Malena. We just have a little bit of time left to take a few questions. So let's start it out with one of the earlier ones. The question is for Pelle, and is when will Wi-Fi 6 be viable, and is Wi-Fi 6E really any better?
Okay, I should just unmute myself. Yeah, Wi-Fi 6 is available. There are plenty of access point manufacturers that have products available, basically since a year back more. We see an interest from industry customers, a take-up in the interest from the last 4 or 5 months. Previously, it has been chip manufacturers, people like us, and access point manufacturers that try to promote the technology. But finally, it's now we see interest from the players in the industrial and even medical market to go into this technology. So we get requests for solutions. And the second part of the question is Wi-Fi 6E really any better? Yeah, 6E is just an extension, open up more frequency band, more available band in the network. It still will operate with a Wi-Fi 6 technology, but it's doubling or almost tripling the amount of frequency available, so you can have much more planning, much more devices in networks. Okay.
All right, thank you, Pelle. And I have another question here for Ludger. In particular, 5G with release 16 and 17 will take some time to become available. So should you wait to use these wireless technologies for a factory deployment?
Definitely not. So in my opinion, the technology is the current LTE technology was released 13, 14 is available and can solve challenges already in a factory, like predictive maintenance and remote services. So 5G and as well Wi-Fi 6 is not a one-fits-all technology. So looking simply on the application, the spectrum of available technologies allows really to solve a lot of activities and a lot of requirements already in a factory environment, and by taking care on the standardization point of view that current technology can be used in new environments allows as well the implementation already now and not just waiting for the next 3 or 4 years.
All right, thank you. And maybe one additional question that we can squeeze in at the last minute. If we haven't gotten to your questions, we will try to respond to them separately after this webinar. So last question for Pelle to close it out. For real-time applications, there's IO-Link Wireless. Are you involved in this? And Pelle, you're on mute.
Sorry about that. It's getting late here in Sweden. Yeah, that's correct. That's correct. There is a technology called IO-Link Wireless. IO-Link on a cable is a protocol between a sensor and a gateway, and the gateway will then forward the industrial sensor actuator data to and from the industrial network. Since more than a year ago, there is a specification for a wireless extension to this IO-Link protocol. We are following it very closely. We have been talking to some players in the market. The interesting here is that it runs on with some modification on standard BLE hardware. It can provide reliable and real time for critical application, very low latency. That being said, there is also one technology, a software technology that can run on basically standard Wi-Fi hardware. A technology called Echo Ring by company R3 Communication. that also provides reliable, low latency, real-time applications. So we're looking into both these technologies as they can run on standard hardware, but so far we haven't decided what if and when to enter. Okay.
Thank you, Pelle. Thank you, Ludger. And special thanks, of course, to all of you who listened today. Yes, let us know what you thought about this webinar in the survey that will be sent to you just now. And I hope that we will see you for our next webinar. And until then, stay safe and healthy and have a great day. Bye-bye.
Thank you.
Bye-bye.
Bye. Take care.